So today we're going to go over chapter 10, section 5, which is angle relationships in circles. So we're going to start with theorem 10.14, which is tangent and intersected chord theorem. It states that if a tangent and a chord intersects at a point of a circle, then the measure of each angle formed is 1/2 the measure of its intercepting arc. So for example, if I have this arc equaling 250 degrees, and I have this red arc at 110 degrees, then I'm able to say that this is 55 because it's half of 110, and this is going to be 125 because it's half of 250. The way I got the 250 and the 110 is I just made up a number and subtracted it from 360. And remember that angles on the tangent must add up to 180. So 125 plus 55 equals to 180. Now we're going to go over theorem 10.15, which is angle inside the circle theorem. So just so you guys an idea, this is going to look like a floating angle. So let's read it. If two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measure of their arcs intercepted by the angle and its vertical angles. Now, what does this mean? I'm going to get this one to equal 40, I guess. I don't know why I wrote 80. Let's say this is going to equal 40. This is going to be 120. This is going to be 80. And this remainder one's going to be 120. What are the things to look for when we're trying to solve for these type of angles? Well, this is, to start off, this is not central angle, so it cannot be a central angle or an inscribed angle. We have seen central and inscribed, and this does not work for either of these. So how do we solve for it? So for example, if we're trying to solve for angle 1, we can do that it's going to be 1/2. The measure of CD is 80, the arc, plus the measure of the arc AB, so 40. That's going to give me 1/2 of 120. So that tells us that angle 1 is 60 degrees. Now you can find angle 2 two different ways. The first one being, again, 1/2 times the measure of AD, so 120, plus the measure of BC, 120. So it's going to be 1/2 of 240, which is just 120. That's how we get angle 2. Now these are vertical angles, so they're going to be congruent to each other. But another way you could have gotten angle 2 is by doing 180 minus 60, and we would get a 120. The reason you can do 180 minus 60 is because it's a straight line, and any angle of a straight line is 180 degrees because they're supplementary angles, and you should be able to solve it either way. Now we have theorem 10.16, angles outside the circle theorem. If a tangent and a secant, two tangents or two secants intersect outside of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepting arcs. So, for example, in this first one, we have two secants. I'm just going to name them. In this one, again, we have two tangents. And in this one, we have a tangent and a secant. So, in other words, the angle of measure 1 is going to be the degree of arc x minus the arc y divided by 2, or 1/2 times x minus y arc. Now, you can always think of it as big arc minus little arc, all of that over 2. That's how you're going to get the angle. It's the same formula, it's just without so many letters. We have circumscribed angles as well. So a circumscribed angle is an angle whose sides are tangent to a circle. So just as an example, this is the circumscribed angle. It lays outside of the circle, but that's tangent to the circle with the lines. Now we have theorem 10.17, which is circumscribed angles theorem. The measure of a oh my god, I can't say that word today. Angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. So we have angle ADB, this one right here, is going to be 180 minus ACB. ACB being the central angle. So we're going to find this, the measure of the circumscribed angle, by subtracting 180 minus the central angle. The key word right there is central. So we have example 1. UT is tangent to the circle. So they want us to find the measure of arc WT. The arc of WT is this one right here. How are we going to find it? We can do the big arc minus the little arc divided by 2, for example. So what's the big arc? The big arc is going to be everything else. So the big arc is actually this arc right here, which is 100, following the lines. So following the lines, we're going to do big arc, so 100, minus little arc, which is what we're trying to find. So I'm going to call that x over 2 equals to the angle that we have, which is 30. So I'm going to multiply both sides by 2 to cancel this fraction. So it's going to leave me with 100 minus x is equal to 60. So that's going to be, I'm going to subtract 100 on both sides. That's going to be x is equal to negative 40. Sorry, negative x is equal to negative 40. So that's going to be x is equal to 40. So that's our answer right here. So I'm going to write that is 40 degrees, that arc, remaining arc that we have. So the second one, they want us to find the measure of angle TVS. TVS is this angle right here. So we're going to use the floating angles theorem, kind of. That's not really the name, but it's going to work. So the way we're going to find it is we're going to do 100 plus 110 divided by 2. So we're going to get 210 divided by 2. So angle TVS is going to be 105 degrees. Now they're asking us to find angle RBS, which is this one right here. I'm going to mark it with 2. Now we can do the same floating angle theorem equation, or we can just do 180 minus 105. So that's going to be 75 degrees. So 75, 105. And lastly, they want us to find arc RS. Arc RS is this one right here. And we can find it 2 ways. The easiest, if I may say so myself, is going to be to add up all the arcs and subtract from 360. So if I do 100 plus 110 plus 40, I'm going to get 250. And if I do 360 minus 250, I will get 110. So that is the remaining arc to make this full circle. And example 2, if the measure of arc AB is 105, then what is angle D? Angle D is what we're trying to find out here. This angle, or this arc right here, is 105. That is given. So we're able to get the remainder arc, which is this one right here, that we're going to need. I'm going to do 360 minus 105. So that's going to be 255. And because they want us to find that circumscribed angle, we're going to do the big arc minus the little arc over 2. That's going to equal our angle D. So the big arc being 255 minus the little one, which is 105. All of that divided by 2. That's going to give us 150 divided by 2, which is going to give us 75. So our angle D is 75 degrees. So they want us to find the measure of arc AB. Arc AB is the big arc. We have the circumscribed angle. So if we do big minus little over 2, it's going to equal the outside angle, which is 10. So our big is our x. I'm just going to call this x. Minus 20, which is our little, over 2 is equal to 10. So I multiply this times 2 on both sides. To get rid of this fraction, I'll get x minus 20 is equal to 20. I'll add 20 on both sides, and that's going to leave me with x is equal to 40. So that is how much that arc is, 40 degrees. Example 4, they want us to find the value of x, and the value of x is angle ADB. Remember, angle ADB, the outside angle, equals 180 minus the measure of angle ACB. Now, angle ADB is our x. We have 180, which is part of the equation, or the equation. And then angle ACB is this angle right here, which is 135. So the x is going to equal 45 degrees. So we use the circumscribed angle theorem to solve for this from the previous pages.